Hi guys, today I'm going to talk about the moment of change trim. So what is trim? By moving away W from its initial point to a new position H forward. The trimming moment will be WH. This will be cause the center of gravity of the ship to move from G to G1 and the ship will trim causing B to move to B1. So sa inyo nakita karon, mao na ang example sa change of trim from the initial position of the weight from the aft of the ship move from the forward of the ship. So when the weight changing from its initial position to a new position, the gravity of the ship and the buoyancy of the ship mausab pod. So mao ni siya dire G1 and B1. Hi guys, para masabtan pa, mao ni ang barko. Let's pretend this is barko and usa na waterline diari. So plain na siya, no change of draught, level na kay siya level. So kung ana siya ang iyang gravity and buoyancy na sa ubos stipo tra, walay change, wala pa yung objective sa baba siyang barko. So mani ang forward, mani ang up. So magbutang tag object dari sa up niya na imitabo nga mo unlod ni ang iyang up. So ang iyang forward mo wala po siya mo hangad tungod siya mo hangad. Ang iyang level of draught mo lower, ang iyang level of draught sa up mo higher. So kung change of trim pala, basta change of trim, kung magbalinta sa from initial position to new positions of the weight, mausap po na ihang gravity and buoyancy.
So, good morning ma'am. My topic for today is the moment to change trim, MCT. 1 meter is a convenient figure to quote to show how easy a ship is to trim. It should be noted that whilst most authorities use a metri as the unit change, some use the MCT by 1 centimeter. It is recommended, therefore, that the full title is given e.g. MCT 1 meter. So, based on my understanding of this topic, ma'am, is there is difference between moment to change and the change trim. So first is the moment to change, or the MCT 1 centimeter, or MCTC is the moment required to change trim by 1 centimeter and may be calculated using the formula MCT 1 cm equals WX GML 100L, where W equals the vessel's displacement in tons, GML equals the longitudinal metacentric height in the meters, equals the vessel's length. So the other one is the change of trim. So change of trim may be defined as the change in difference between the drops forward, the aft. Changes of trim are produced by shifting weights forward and aft, or by adding or subtracting weights forward of or above the axis about which the ship trims center of flotation. So the change of trim can be calculated by the formula of where the trimming moment is WXD, and the second is W being the weight shifted, and D is being the distance through which the weight is shifted longitudinally.
So, additional stiffening in the pounding region. If the minimum design draft forward in any ballast or part loaded condition is less than 4.5% of the ship's length, then the bottom structure for 30% of the ship's length forward in seagoing ships exceeding 65 meter in length is to be additional straightened for pounding. So these forces are induced due to the slamming motion of the ship triggered due to the heaving or high pitching motions. This situation is further aggravated in case of empty or light ballast conditions of ships. So this intense pounding stresses incidence on the planting spread over a large area extending a considerable amount of length even behind the forward collision's bulkhead. Slamming can be mostly bow flare slamming, stern slamming, or bottom slamming. So as this when a ship sails in heavy seas, it pitches. It can happen that the bow rises over the crest of a wave and emerges completely out of the water. And when the bow comes back down the water, it can be subjected to a major impact that causes pounding.
So if the double bottom is longitudinal frame in the founding region, where the minimum design draft forward may be less than 4% of the ship's length, solid plate floors are fitted at alternate frame spaces and intercostal side girders fitted at a maximum spacing of 3 times the transverse floor spacing. So it was said that when the double bottom is longitudinal, when we say longitudinal, in other words, it is vertical, in which the minimum distance between the water line and the deepest point of the ship or draft is less than 4%. Solid plate floors are fitted at alternate frame spaces. So, an intercostal side girders fitted. When you say girders, it is a steel beam or compound structure used to make or construct frameworks or large buildings. So, at a maximum spacing of 3 times the transverse floor spacing. So, where the minimum design draft forward may be more than 4%, but less than 4.5% of the ship's length, solid plate floors may be fitted at every third frame space, and intercostal side girders may have the maximum spacing of 4 times the transverse floor spacing. As longitudinal are stiffening the bottom shell longitudinally, it should be noted that fewer side girders need be provided than where the bottom is transversely framed to resist distortion of the bottom when the slamming forces is experienced.
Hello everyone, good day. This is Karen Alisna, and today we're going to talk about true main draft. True main draft. Effect of hug and sag on the draft amidships. When a ship is neither hug or sag, the draft amidships is equal to the mean of the draft forward and aft. A ship's true main draft is measured at the center of flotation and may not be equal to the average of the draft forward and aft. When a ship is trimmed by the stern and the center of flotation is aft of amidships, the correction is to be added to the mean of the draft forward and aft. Now consider the ship shown in figure 25, which is trimmed by the stern and has a center of flotation forward of amidships. In this case, true mean draft equals draft amidships. Correction. The actual correction itself can again be found by using the above formula, but in this case, the correction is to be subtracted from the mean of the draft forward and aft. Similarly, by substituting forward for aft and aft for forward in this figure, it can be seen that the correction is again to be subtracted from the average of the drafts forward and aft when the ship is trimmed by the head and the center of flotation is aft of amidships. A general rule may now be derived for the application of the correction of the draft amidships in order to find the true mean draft. This chapter discusses the true mean draft of a ship. A ship's true mean draft is measured at the center of flotation and may not be equal to the average of the draft forward and aft. When a ship is trimmed by the stern and the center of flotation is aft of amidships, the correction is to be added to the mean of the drafts forward and aft. The chapter derives a general rule for the application of the correction to the draft amidships in order to find the true mean draft. When the center of rotation is in the same direction from amidships as the maximum draft, the correction is to be added to the mean of the draft. When the center of rotation is in the opposite direction from amidships to the maximum draft, the correction is to be subtracted. And that's all, and thank you.
Good day, everyone. I am Lemuel James Amakna, and I am here to report true mean draft. So let us say, for example, that the vessel being sagged caused by the broken outline. So sagging is the condition of a vessel caused by the unequal distribution of a cargo. When a vessel loads too heavily in the center, it causes a bending downward of the hull at the midship area. This can also be caused by the vessel working in heavy seas with large waves under each end and no support under the center of the ship. So, when the vessel sags, the draft amidship changes into K1x, which is equal to the mean of the draft forward and aft, or shall we say Kx plus the sag Kk1. The amount of hug or sag must therefore be taken into account in calculations involving the draft amidships. The depth of the vessel amidships from the keel to the deck line, Ky or K1 Y1 is constant, being equal to the draft amidship plus the freeboard.